Okay, since we have finished chemistry, I mean till stoichiometry, I'll give a pause to chemistry. Okay, now I'll give you an introduction to electrostatics, quite an important thing in physics. Okay, first of all, I'll start with the basics. Consider we have a charge, a positive charge, another positive charge over here, okay, and a negative charge over here. I'll do it another color. Okay, now what will be the attraction or repulsion going over here? This will actually move towards this, right? And this will actually move towards this, because opposite charges attract each other. And what about the like charges? What will they do? They will repel each other, right? Repulsion will happen between like charges, and attraction will happen between unlike charges. And that is the basic principle of electrostatics, right? Now, what is the basic unit of charge? I mean the SI unit of charge. What is it? It is Coulomb. C. I'll write it down. Coulomb. Coulomb is a person who got his head into electrostatics. I don't know much about him. I gave an introduction to him. Okay, now first of all, I will write down some constants which are quite important in doing problems, and quite simple, you know. Okay, now what is the charge of one electron? Charge of one electron is equal to 1.6 into 10 raised to negative 19 Coulomb. That is the charge of one electron. Now you might want to put that in a box. Quite important. Okay, now what is the charge of one proton? 1p plus. Sorry, I made a big mistake over here. This is actually minus 1.6. To be noted, minus 1.6, and the charge that of a proton is charge that of a proton is not minus 1.6. It's actually positive 1.6. Positive 1.6. That is the charge of one proton. Quite important. You should actually these values are actually quite important. Okay, now we'll actually do it in reverse. Okay, now to find out how many electrons make one Coulomb. Okay, how many electrons? Let me change the color. Okay, how many electrons? Therefore, we know that one electron gives a charge of 1.6 into 10 raised to negative 19 coulombs. Therefore, Coulomb, 1 Coulomb is actually equal to 1 by, we don't actually have to consider the negative because it's actually the number of electrons. 1.6 to 10 raised to negative 19. Right, 10 raised to negative 19. Let me take my calculator. Yes, I have it over here. Now first we can actually have the power in a calculator, so we'll do 1 by 1.6. What is that? 0.625. Let me write that down. 0.625. So actually this goes up, so it becomes 10 raised to 19. Actually 10. Wait, I'll write it again. 10 raised to 19. This is also equal to 6.25 into 10 raised to 18, right? Into 10 raised to 18. Okay, 1 Coulomb, I mean 6.25 into 10 raised, okay, I didn't write 10, simply wrote 18. into 10 raised to 18 electrons make 1 coulomb. They make a charge of 1 coulomb. Okay, now finish with the basics. Yup. Okay, now Coulomb there is a Coulomb's law, and I don't Coulomb's law. I mean, I have a doubt whether Coulomb's law. Here I'll just put a full stop. Okay, I just give you what Coulomb's law infers. It infers that, I don't know Coulomb's law exactly, I'm not saying it. It actually infers that the force between two charges is equal to, and then he has an equation. The force between two charges is equal to, this is the force between two charges, so vector is equal to a constant k into the first charge into the second charge divided by d squared. Now this is a very important equation. You must write it down. Oops. Okay, that was quite foolish of me. I'll move this here. I'll just remove this. Not this one. Okay, now this is exactly what you will see in the equation for the force of gravitation. Fg. What is Fg? G into m1 into m2 divided by d squared, right? Somewhat similar to this, right? Somewhat similar to this. Okay, that is somewhat similar, just to show that. Now what is this k over here? What is this k? What is this k? We have a value for k. K is 9 into 10 raised to 9. The unit, we actually get the unit if we divide this and multiply it. It's actually force into area, right? Newton meter square divided by, these both are coulombs, right? So they make coulomb square. So that is the value of k, and I do think it's quite important. So it's better you, oops, made it again. I think it's better you note it down. Quite important. Okay. Now I'll do a problem to give you an idea of what is this charge. Suppose we have some charge, positive. It's positive, and we have another charge over here. I'll do it in another color. What color? Green. Another charge over here, and it is negative. Okay, now I'll give values for both. What is the value for the positive charge? Let it be 5 into 10 raised to what should I give? 10 raised to negative 3. Okay, coulombs, right? Yes. And what is the charge of this? It should be minus 10. Let it be do 10 raised to minus 2 coulombs. Now let this distance be, the distance between these two charges be, let it be 10 meters. 10 meters. Okay, now we need to calculate the force. We know that the equation for force is equal to k, constant 9 into 10 raised to 9 over here, into q1. What is the first charge? 5 into 10 raised to negative 3. I'll copy paste that. Yes, that is the first charge, right? Now what is the second charge? This is the second charge. into this, right? Into this. Now divided by d squared, right? 10 into 10, right? Okay, now I'm gonna remove these. I hope you have written them down, white and bottom. Now we need to find the value of this, right? This actually becomes, let me change the color, 9 into 5, 45 into 10 raised to 9, therefore this minus 10 raised to 6 minus 2 10 raised to 4 into minus 10, right? Therefore this will be, okay, we have a divide by 10 raised to 2, right? No, we can actually subtract that. Alright, subtracted. This will be 10 raised to 2. Okay, 45 into negative 10 raised to 3. That is the answer of 4.5 into, okay, let's state it that 45 into negative 10 raised to 3, right? Okay, or we can write it as negative 4.5 into 10 raised to 2, right? It's actually 2, right? Sorry, it's not 2, it's actually 4. So that is the answer, that is the force between them. So the new unit is Newton. Okay, I've actually run out of time. See you in the next video.